All right, welcome to our lesson on polynomial division. We did cover this briefly in the beginning of the year, so it may sound familiar. So starting with number 1, which says, is x minus 5 a factor of x squared plus 6x minus 45? So if something is a factor of something else, for example, 3 is a factor of 12. So when we divide 12 by 3, we get an integer with no remainder. So you may want to add that to the what is important to remember box. I'll give you a moment to do that. So if something is a factor of something else, then you will get no remainder. If you get a remainder, that means it is not a factor. So if I divide 12 by 5, I'm not going to get an integer, which means that 5 is not a factor of 12. So we're going to use that to our advantage here, and we are going to divide x squared plus 6x minus 45 by x minus 5. Remember that x minus 5 is the divisor. It's the thing that's doing the dividing. And x squared plus 6x minus 45 is the dividend. The quotient is what we'll get when we're finished. So we're asking ourselves, what do we have to multiply x by to get x squared? And that would be x. So then we multiply x times x is x squared. X times negative 5 is minus 5x. At this point, we're subtracting. So we're going to set up subtraction bar, put everything here in parentheses, big subtraction sign so we don't forget. X squared minus x squared cancels out. 6x minus negative 5x is actually 6 plus 5, so 11x. And then we start over. What do we have to multiply x by to get 11x? Would be positive 11. Then we multiply. I'm going to bring down my minus 45 first. Then we multiply. 11 times x is 11x. 11 times negative 5 is minus 55. Subtracting, put the second expression in parentheses, subtraction sign. 11x minus 11x cancels. Negative 45 minus negative 55 is positive 10. This right here is our remainder. So we do have a remainder of 10. So to answer this question, is x minus 5 a factor? It is not a factor. And our quotient so the result that we get when we do that division is x plus 11, and then we write our remainder like this, 10, and that 10 is supposed to be divided by x minus 5, but we can't. So plus 10 divided by x minus 5 is our remainder. And so this is the result that we get when we attempt to do that division. Okay. In number 2, we are asked, is negative 1 a root of f of x equals that polynomial? So if it's asking us about negative 1 being a root, then it's really asking us, is x plus 1 a factor, right? Because x plus 1 is the factor that would go with negative 1. So we could repeat the same exact thing we just did. We could do long division. We can also use what's called synthetic division. And synthetic division uses just the root and the coefficients of the polynomial. So we're going to set up synthetic division here. Synthetic division gets set up with a structure like this. The root goes right here, or the possible root, and then the coefficients are going to go right here. So starting with the highest degree, making sure it's in standard form, which it is. So 2, negative 13, 3, and 18. So our coefficients from the polynomial. And then here's how we perform synthetic division. We're going to bring this 2 down, and then this 2 gets multiplied by this negative 1. So 2 times negative 1 is negative 2. Then we're going to add. Negative 13 plus negative 2 is negative 15. Then we repeat the multiplication. Negative 15 times negative 1 is 15. Add, 3 plus 15 is 18. Multiply. 18 times negative 1 is negative 18. 18 plus negative 18 is 0. Each of these numbers down here represents something, okay? So this right here represents the remainder. So because there is no remainder, that answers our question. X plus 1 is a factor of f of x, and that means negative 1 is a root. So let's make sure we answer that. So yes, negative 1 is a root of f of x because there is no remainder. These three numbers right here represent the leftover parts of the quotient. So just like we had our quotient here, x plus 11, the 2, negative 15, and 18 represent the parts of that remaining polynomial. So the 18 is the constant. It's a positive 18. Then if we think about the next term would be an x term. This represents minus 15x. And then the next term after an x would be an x squared. This 2 represents 2x squared. So when we divide this polynomial by x plus 1, we get this. Now, at this point, we have strategies for factoring quadratics. So we can keep going and we can see what other roots f of x might have. So go ahead, factor, and come back, pause and come back when you are ready to check your factors of this polynomial. Okay, so after factoring, you should get 2x minus 3 and x minus 6, and that is equal to 0. So we can find the other roots. One of them would be 6, and one of them would be positive 3/2. So f of x actually has 3 roots, and if we rewrite f of x in factored form, making sure that we include the first one we found, so x plus 1, and then the 2 we just found. This is, oops, not plus. This is the same function, just written in factored form. Now, this, if we had tried to factor it using our factoring strategies, we would not have been able to, and that's because we get 3 linear factors. So performing synthetic division here allowed us to find all those remaining factors. All right, our last one here says find all zeros given that x equals negative 4 is 0, and then sketch the function. So we can use the same strategy we just did. We can do long division or synthetic division. I'm going to suggest synthetic division. This time they're telling us, not asking us, that negative 4 is a 0. So setting up synthetic division, making sure this is in standard form, which it is. However, we're missing the x squared term. So when we pull our coefficients, we're going to put a 0 for that x squared because it's missing here. And then we're going to perform synthetic division. So 1 comes down, 1 times negative 4, add vertically, multiply again, add vertically, multiply one more time, add vertically just to make sure we get a remainder of 0, which we do. And then we're going to extract these 3 coefficients. So this is a constant of 3, this is a linear term minus 4x, and this is a quadratic term 1x squared. Now we can factor this quadratic. So go ahead, pause, come back when you're ready. So our factors are x minus 3 and x minus 1. Oops. And we are asked to find all zeros. So now that we have our factors, we can say that the last zeros are 3 and 1. And then we're going to use all of that information to sketch the function. It's also important to note our multiplicity. So we have 3 factors, each with a multiplicity of 1, because each of them only appeared one time. So the factor that would go with negative 4 is x plus 4. And then our other two factors. So we know that we have a 0 at negative 4. And we have a 0 at 1 and at 3. Then we're going to think about our end behavior and which direction this is going to be facing. So we have a positive leading coefficient and an odd degree. So that means it's going to be down on the left and up on the right. And again, each of the multiplicities is 3. We can also find our y-intercept. Remember that y-intercept is our constant. So we can add that here. Kind of gets a little cut off there, but you get the idea, okay? And I think we have everything we need. So we know it's going to be coming from this direction, okay? It's going to go up, touch our y-intercept. Now, it could keep going because there's nothing that says there has to be a turning point there, but I'm out of space, so I'm going to bring that back down. Again, multiplicity of 1 means it has to cut through the x-axis. And we don't know how low it goes, so we're just going to eyeball it and then have it turn around and come back through here. Now this is just a sketch, so we could make this better by plugging in some other x values, okay? And then we could figure out exactly what this cubic function is going to look like.